Hi, my name is Christian, and my presentation is on design patterns with a specific focus on the bridge pattern. Let's get into it. What even is a design pattern? Let's explore a usable definition. In software design, there are commonly occurring problems. A design pattern is like a blueprint that you can customize to solve these problems in your code. Design patterns are not plug-and-play solutions to problems. Instead, they offer a general concept that typically leads to a functioning or more efficient solution. We are all familiar with algorithms that describe a clear set of actions to achieve a goal. Alternatively, design patterns are a higher level description. Design pattern classifications. There are three categories for design pattern classifications. There are creational design patterns, structural design patterns, and behavioral design patterns. First, creational design patterns deal with the creation and initialization of objects. Secondly, structural design patterns deal with assembling objects and classes into larger structures. And third, behavioral design patterns focus on the interaction and communication between the two classes. But what design pattern to choose? Well, today I will be focusing on the structural patterns, which is one of the classifications. Structural patterns explain how to assemble objects and classes into larger structures. It also provides a framework to keep these structures efficient and flexible. The gist is, structural patterns help organize and manage relationships between classes and objects. When these relationships are correctly managed, we avoid problems like tight coupling and rigidity. Within the structural pattern classification, there is a design pattern called Bridge. When researching the differences between design patterns, this specific one stood out to me. Basically, it allows you to split a large class or related classes into separate hierarchies. These hierarchies are known as abstraction and implementation. If you're like me, reading these terms inspires a crippling sense of imposter syndrome and existential dread. So, let's try to break them down into a more digestible form. Abstraction provides high-level control logic. This represents the interface that clients interact with. Abstraction defines the operations or functionality that the client have access to. Then it references the implementation object and relies on it to do the actual work. Implementation means the implementer interface or class defines the contract that concrete implementations must adhere to. It encapsulates the low-level implementation details. Together, the bridge pattern allows you to have multiple abstraction and implementer classes that can be combined when you need them. What is this pattern solving? Why would we even use this? Well, we would implement the bridge pattern when we have a complicated system with a lot of parts that compound complexity. If you have many abstractions and implementation classes, decoupling them allows the creator to divide and organize them so they have several variants of functionality. When a system is highly coupled, figuring out how it works and worse making changes is significantly more difficult. If you wanted to change one functionality, that may require making changes to the entire class. This often causes unforeseen problems since everything is so intertwined. The bridge pattern allows you to split up your class into several class hierarchies. After applying this pattern, you can change the class in each hierarchy independently from one another. Using this pattern simplifies code maintenance and makes adding additional code or making changes much easier. In the bottom left, I have a picture of something overly complicated. It's a self-operating napkin. So, how does the bridge pattern work to solve a problem? First, the bridge pattern separates abstraction and implementation. The bridge pattern gives the client an abstraction layer that is a high-level interface for clients. This abstraction layer defines the functionality that the clients can utilize. Secondly, the bridge pattern encapsulates implementation. The implementer interface encapsulates the low-level implementation details. Third, it decouples and composition. The abstraction and implementer are connected via a bridge. This allows the two separate classes to be independent. This form of decoupling allows the developer to combine different abstractions with different implementers. Finally, reducing class explosion. This pattern enables each class to act independently. So, instead of having a class for each possible combination, you can have a smaller number of abstractions and implementations that can be combined as needed. How would we use the pattern to solve a problem? First, we would find the independent dimensions in your classes, like color of the car or functionality that it provides. Then we would determine what operations the client needs and defines them. We would declare the operations that the abstraction needs in the general implementation interface. Then we would create implementation classes that follow the implementation interface. Then we would, inside the abstraction class, create a reference for the implementation. The abstraction class delegates the low-level work to the implementation object that is referenced. Finally, the client should be able to pass an implementation object to the abstractions constructor. After that, the client can ignore the implementation and only focus on the abstraction object. Let's go over some appropriate times to use the design pattern. The dreaded class explosion. You would implement the bridge pattern when there are multiple variations of abstractions and implementations. This can lead to a problem where you need to make a subclass for every combination. This problem can grow exponentially and is commonly referred to as class explosion. Let's say we're creating a car class that includes two subclasses. First there's flying cars and then submersible cars. Now you want to add colors, so you create an orange and green car subclass. Considering we already have two subclasses, you would need to create 4 class combinations like green flying car and orange submersible car. Well, as we all know, there are more than just 2 colors. So if you want to add more types of cars or more color types, the hierarchy would grow exponentially. The more we add, the worse this problem gets. You could apply the bridge pattern to this situation. You could apply the bridge pattern to the situation to which the object away from this type of inheritance. This basically means that you take one of the dimensions of the object into a separate class hierarchy, so the original classes reference an object of the new hierarchy, instead of having all its qualities and behaviors within one class. Let's look at a demonstration of the bridge pattern. First, the program defines an abstract class color, which is implementer interface. Second, there's 2 implementer classes, blue color and red color, that are both defined. These 2 classes inherit from color and perform the apply color function. The program defines an abstract class shape that performs the draw function. Then the program defines 2 abstraction classes, circle and square. Color pointers are passed to the constructors to assign desired color. This example demonstrates how the bridge pattern separates the abstraction, in this case the shape, from the implementation, in this case the color. It allows different shapes to be combined with different colors dynamically, without the need for creating multiple classes for each combination. The bridge pattern helps to manage the relationships between the classes and how they interact. Let's do some simple Q&A regarding the bridge pattern. What's a negative or con about implementing the bridge pattern? You might make the code unnecessarily complicated by applying a pattern to a class that is highly cohesive. What is a positive or pro about implementing the bridge pattern? The client works with the high-level abstractions and is not exposed to the implementation. What is an example of the bridge pattern being applied? When developing the graphical user interface GUI toolkit in many programming frameworks, by using this pattern, the GUI toolkit can support different platforms and UI controls without having to create a separate class hierarchy for every combination. Well, thank you for your time listening to our presentation. Sorry for the overuse of cheesy memes, but I had to throw in a little flavor in there. Thanks so much, and feel free to message me on Canvas if you have any questions.